Imagine a place where the air itself feels like a solid thing, where you don't just breathe the atmosphere, you wear it, heavy, wet, hot. This is not hell, this is Earth, 10 million years after fire and chaos wiped the dinosaurs from the face of the planet.
After the extinction of the dinosaurs 65 million years ago, on land, animals diversified. Many new species came to be.
In the aftermath of extinction, the world was left to the survivors, the small, the adaptable, and the resilient. They inherited a planet without rulers. For a time, it was a paradise. A second chance, but in this heat, in this suffocating silence, a new apex predator was about to write its name into the stone.
Along with that, we started to collect bones of an animal that we weren't sure what it was. We thought maybe they belonged to some of the crocodile relatives that we were picking up.
A predator that didn't need speed, or claws, or sharp teeth to conquer the world. It needed only one thing: pressure.
This would have been an animal that, as it was slithering past you, would have slithered by just underneath your waist, and would have been somewhere in the 40 to 50 foot long range.
60 million years ago, the throne of the apex predator was not occupied by a dinosaur. It was occupied by a snake. A creature of impossible size and terrifying design. They called it Titanoboa.
The Serra coal mine provides us with a unique opportunity to open the window into that past, right after the extinction of the dinosaurs in South America. And what we see when we look through that window is the first evidence for the tropical rainforest, including many of the plants that we recognize in the tropics today.
This is not the Paleocene. This is La Guajira, Colombia, one of the largest open-pit coal mines on Earth. It's a place of industry, of extraction, a place where they tear the Earth apart to feed the modern world's hunger for energy. But for paleontologists Jonathan Bloch and Carlos Jaramillo, this lunar landscape is a library written in stone, 60 million years in the making. And in 2009, they found a book they never expected to read.
Along with that, we started to collect bones of an animal that we weren't sure what it was. We thought maybe they belonged to some of the crocodile relatives that we were picking up.
At first, they thought they were crocodile bones. They were too big, too robust to be anything else. But as they chipped away at the rock, a pattern began to emerge. A pattern that didn't belong to a crocodile. It belonged to a snake.
We're absolutely ecstatic. We were giddy schoolboys.
By comparing the fossils to modern snakes, they could calculate the size of the beast. The result of that calculation was almost too shocking to publish. This snake was not 20 feet long, not 30. It stretched the very limits of vertebrate biology.
This would have been an animal that, as it was slithering past you, would have slithered by just underneath your waist, and would have been somewhere in the 40 to 50 foot long range. And we didn't recognize them as snakes when we were collecting them initially because they were just so large. It would be like finding the bones of a mouse the size of an elephant. You wouldn't expect to see that.
42 to 50 feet, 1¼ tons. A creature so large it would have to weigh 250,000 pounds on Earth's scale. It was and remains the largest snake that ever lived, a monster hiding in plain sight for 60 million years, buried in the coal of Colombia. But the bones told only half the story. The rock itself held the secret to why such a monster could exist. This dark layer, the coal, is the compressed remains of those ancient Paleocene swamps, and locked within it are chemical ghosts. This was the Paleocene Thermal Maximum, a period of intense, sustained global warming. The planet was a hothouse. In the tropics, average temperatures soared. We're not talking a few degrees warmer. We're talking about average yearly temperatures of over 90 degrees Fahrenheit. It was a world without ice. For a cold-blooded reptile, temperature is destiny. A snake's metabolism, its entire engine, is powered by external heat. It doesn't need to burn calories to stay warm. All that energy can be funneled into one thing: growth.
We think is that in the past, 58 million years ago in South America, it was also much hotter. And this is important for cold-blooded vertebrates like Titanoboa because they derive their body temperature from the ambient temperature, the temperature in their environment, as opposed to deriving the temperature from the food that they eat, like a warm-blooded animal does. And because of that, cold-blooded reptiles cannot get beyond a certain body mass without their metabolism slowing so far down that they wouldn't, say, be able to eat at a certain temperature. So on the equator, we have the largest snakes today, and they get as large as they possibly can given the temperatures that they're living in. The only thing that would allow us to build a larger snake would be to relax those temperatures, and those temperatures would become warmer. So we think that Titanoboa became as large as it did because temperatures were maybe even as much as 10 degrees Fahrenheit warmer than they are today.
The snake tells us that the tropics, the very heart of the Earth's climate system, were at least 5 to 10 degrees Fahrenheit hotter than they are today. Titanoboa wasn't just a monster, it was a walking, slithering thermometer, a warning from the deep past. In this world, Titanoboa was the ultimate sit-and-wait predator. It was an ambush hunter on a continental scale. It didn't chase its prey. The prey came to it. Its prey was formidable. The swamps were filled with Cerejonisuchus, a 7-foot-long crocodile, a powerful predator in its own right. But to Titanoboa, it was a protein source, a snack. Unlike a constrictor of today, Titanoboa's power wasn't just about suffocation, it was about cardiac arrest. The pressure it could exert, an estimated 400 pounds per square inch, was so immense, so instantaneous, that it would stop the heart and the flow of blood before the brain even knew it was dying. But even a snake of this size had to choose its battles. This was not a simple world of eat or be eaten. It was a world of titans. Carbonimus, a turtle with a shell of solid bone, thick enough to resist even the crushing coils of Titanoboa.
So I start working with the screwdriver, carefully removing all the sediment that was covering this specimen. Wow, it was a really, really nice moment for me to see this almost 2 meters long turtle coming at the surface. This is the head of the turtle, and this is the shell, the carapace and the plastron of the turtle. It was a surprise for me.
They were the tanks of the swamp, the only creatures that could look the monster in the eye without fear.
They got really thick shells, and that means a lot of bone for a snake to get digest. So it's really not a good idea for a snake to get something that is going to stay in your stomach for so long because it has so much bone on it. So for the largest turtles I saw around, they had so many chances to survive because the snakes probably prefer to eat crocodiles or other small animals.
The world that built Titanoboa did not last. The hothouse climate of the Paleocene eventually cooled. The thermal maximum ended, and with it, the reign of the giants. The snake didn't die because it was a failure. It died because its world changed. It was a specialist in heat, exquisitely adapted to a specific set of rules. When the rules changed, the game was over. Today, we are rewriting the rules. We are burning the very sunlight that fell on Titanoboa's back 60 million years ago, pumping that ancient carbon back into our atmosphere. We are, in a sense, trying to rebuild its world.
People always ask me, does that mean that with future global warming, we'll have larger snakes appearing on the planet? And the answer to that is theoretically, yes, we could get larger snakes with global warming.
The monster is gone. The swamp is silent, but the stone remembers, and in the heat of a new world, it whispers a question we dare not answer. What happens when the monster wakes up?